So Venus and Earth appear to be very similar. However, they appear to be very similar on the surface. They are extremely similar sizes and masses. Venus is only slightly smaller than Earth, about 95% of the diameter. They are similarly dense, and they are formed in the same parts of the solar nebula. However, once you get past these surface level similarities, you'll find that Venus and Earth are actually radically different. One of the most notable differences being that Venus is much hotter, in part because, as we'll discuss later, Venus's greenhouse effect is much more pronounced than it is on Earth. Venus is about 10 times hotter than Earth, with temperatures often reaching upwards of 900 degrees Fahrenheit, making it the hottest planet in the solar system. Its magnetic field is also much weaker than Earth, and that combined with the fact that it's much closer to the sun makes it much more susceptible to solar winds, and Venus is constantly enveloped in gas, which makes it difficult for us to study the planet. And much of this gas is carbon dioxide. In fact, 96% of Venus's atmosphere is just carbon dioxide, with less than 4% of it being nitrogen and 0.5% of it being water vapor. It's completely inhospitable. Well, and this CO2 is part of why Venus is so hot. These clouds also cover much higher than on Earth. They go upwards of 40 to 45 meters above the planet, and these clouds are much more stable than Earth's clouds. The upper atmosphere of Venus is cooler than the lower atmosphere, where, as I mentioned, it can reach upwards of 880 to roughly 900 degrees Fahrenheit, and atmospheric pressure is around 10 times less dense than water. And Venus's atmosphere has a rotation period of only 4 days, which is likely due to the fact that the heated atmosphere, the gas circulates well due to convection. You have the cooler air, that the air cools and rises top and lower. Yeah, and Venus is also extremely dry. However, there is evidence that suggests that it once had a lot of water. However, as it heated up, especially since it's closer to the sun and it has all of this CO2, this water has since evaporated. It also has no ozone layer. And as I mentioned, Venus's greenhouse effect is much more pronounced than on Earth because its atmosphere is 96% carbon dioxide compared to the Earth, where it's only about 0.04% carbon dioxide, which causes these insane temperatures on Venus where basically nothing can survive. And this carbon dioxide traps heat in Venus's atmosphere, and then it can't leave the atmosphere, which causes the planet to heat up as it would on Earth. And due to the fact that Venus is close to the sun, well, the amount of CO2 produced is similar to Earth, but Earth was able to convert most of that CO2 into sediments. Much of it got trapped in the ocean, and because it's not as close to the sun as Venus is, heat traveled there less quickly. So a lot of the heat traveled to Venus faster. It got trapped in the atmosphere, and then eventually, when oceans started evaporating, much more of the CO2 was released, which meant that even more of the atmosphere could trap heat more effectively. And now Venus is so hot that the greenhouse effect, the toxic gases have been taken out of the rock formed on Venus and released into the atmosphere. And Venus's surface is very difficult to observe due to the constant cover of clouds, but we know that its composition is mostly basalt with extreme temperatures and extreme pressure, which is another factor that makes it inhospitable. There have been attempts to explore the surface of Venus in the past, but many of them didn't get very far, in part due to these extreme temperatures and pressures. Venus's surface is made up of old lava flows, which create very rough terrain with both extreme highlands and lowland plains, and often Venus is depicted as being an orange color. This is a false color that's used, or that's a false color image from radar maps because humans can't see radio waves, so people needed a way to be able to depict Venus. In reality, the surface is more or less a dark gray. And Venus has a very large amount of volcanoes. However, unlike Earth, which contains two types of volcanoes, Venus only has shield volcanoes, which are notably not produced by plate tectonics. There's a lot of evidence that Venus does not have plate tectonics, unlike Earth, and these shield volcanoes are very large due to repeated eruptions, and it's very likely that there are many active volcanoes on Venus, but we cannot determine that for sure. And they also have these things called coronae, which are upwards of 2,100 kilometers tall, and they have volcanic peaks and lava flows. And one of the strangest aspects about Venus is its rotation. So in the 1960s, around 1962, a radio pulse was sent to Venus, and the echo came back instead of as one precise wavelength as two different wavelengths, one longer and one shorter. And by applying the Doppler effect and knowledge of redshift, particularly the fact that the side that came from the western part of Venus was blue shifted, scientists were able to determine the period and direction of Venus's rotation, and they found that it takes 200. It has a very slow rotation at 243 Earth days in order to complete a full rotation, and oddly, it rotates in a retrograde clockwise motion. Essentially, it rotates backwards. And another odd facet about its orbit is not only is it very slow, its rotation is longer than its orbit, which is only about 224 Earth days. And there are two theories as to why Venus has such a or why Venus orbits in the direction that it does. The more classic theory is that it was struck off center by a large object, similar to how many believe the moon was formed, and another model supported by some math was that solar tides were changed, or was that solar tides were responsible for changing the rotation, and these solar tides were able to because of the molten core and dense atmosphere of Venus. So, yeah. Bye. Oh.